Hey, trigonometry class, this is our lesson on section 3.3. You're going to be looking at the unit circle and something called circular functions. We've looked at circular functions before in our college algebra class, and we're just going to compare it to what we know as the unit circle. And that's all I'm going to do is briefly mention that as circular function. And then we're going to be looking at finding values of circular functions and then determining a number of with a given circular function value. So we're just applying a lot of these things that are called circular functions to the unit circle, to what we know as the unit circle now. Okay, so let's get started. All right, you all should have one of these unit circles that we have filled out in class, and we're going to keep on referring back to this unit circle right here to help us in figuring out some of our answers in our examples. All right, going back to this page over here, I wanted to mention this down here, that the unit circle has this equation. That is our circular function for the unit circle. X squared plus y squared equals 1. Now let's look at this. So for any of our circular function values, this is how we're going to find these values of sine, cosine, tangent, and their reciprocals. So sine of s is equal to our y, because our r in our unit circle is 1. And same goes for this one, it's still 1. And then tangent, you find it by y over x. And then cosecant of s is just the reciprocal of this right here. So 1 over y is what you get. And cosecant, same thing, except 1 over x is what you have. Then again, tangent and cotangent are reciprocals, so flip y over x with each other, and you have x over y. We have looked at a Pythagorean identity before, and the other two Pythagorean identities that go along with this one right here. But this is how we come up with our Pythagorean identity, is we have our unit circle. This is the equation for our unit circle. And since we know that cosine of s is equal to x and sine of s is equal to y, then we can replace cosine of s and sine of s into our x and y here, and we get one of our Pythagorean identities. So cosine squared s plus sine squared s equals 1. And then from this Pythagorean identity, we can rearrange things and come up with the other two identities that we have looked at before. All right, so here we are at our first example, and we have, this is what we want to find, the exact values of sine of negative 3 pi, cosine of negative 3 pi, and cotangent of negative 3 pi. So this is what I'm going to do. I'm going to draw out what angle this is. So we're going in a negative direction. 3 pi, we go around this thing once, that's 2 pi, and go halfway more around, that is negative 3 pi, the angle right there. And if we had our unit circle drawn on this thing, let's go ahead and draw it, you would see that this angle intersects this line at this point, which our point on this unit circle is negative 1, 0. So we can use these values right here for our sine and cosine, like I've taught you in class. So sine of negative 3 pi is equal to our y value, which is 0 in this case. And then cosine of negative 3 pi is equal to our x value, which is negative 1. And then our cotangent. Cotangent of negative 3 pi. Remember, that is our x over y. So in this case, it is negative 1 over 0, which means this thing is undefined. Okay, so that's how we do our first example. All right, this next example asks us to use the figure to find the exact values of sine of 4 pi over 3 and cosine of 4 pi over 3. So locate 4 pi over 3 on your unit circle, which is right here. And these are our sine and cosine values right here. So sine, remember, is your y value. So looking at the unit circle, our y value is this right here, negative square root of 3 over 2. And we're done with that one. And now cosine of 4 pi over 3, very similar, it's our x value. So this is going to be negative 1/2. And we're done with that one. Okay, on this one we are asked to find tangent of negative 9 pi over 4. This is how I would do it. I would take this negative 9 pi over 4 and just like finding the coterminal angles that we did in our last chapter, instead of subtracting or adding 360 degrees, one full circle in radians, one full revolution is 2 pi. So take this negative 9 pi over 4 and add 2 pi instead of 360 degrees. And what we're going to get here is, let's see, negative 9 pi over 4 plus 2 pi. Well, let's see, change that to 8 pi over 4. And we get negative pi over 4. Well, let's do that again. Let's add 2 pi. And when we do that, that is going to get us, let's see, 7 pi over 4. So 7 pi over 4 and negative 9 pi over 4, same angle. They're coterminal. So let's look at 7 pi over 4 and its x and y values to find what tangent of negative 9 pi over 4 is equal to. So tangent of negative 9 pi over 4 is the same thing as finding tangent of 7 pi over 4. And here are x and y values. Remember, tangent is x or y over x. And you're going to have negative square root of 2 over 2 over square root of 2 over 2. This is equal to negative 1. And we're done. All right, another way of finding sine, cosine, and other sorts of trig function values is by doing as directed here. It says use reference angles and degree/radian conversions to find the exact value of this sine 11 pi over 6. So what I'm going to do is take this here, convert it to degrees. This is what we get, 11 pi over 6 times 180 over pi. And that gives us 330 degrees. Well, now find the reference angle to 30. The reference angle is going to give us, well, 360 degrees minus 330 is 30 degrees. Now, let's find sine of, in this case, since we are in, this tells us we're in the fourth quadrant, sine is going to be negative in our fourth quadrant. So we're finding negative sine of 30 degrees. And that's going to get us negative 1/2. Because if we go back to this chart right here, this unit circle, sine is what we're looking at of 30, and our y value here is 1/2. And that is what we got, negative 1/2. Now in this example, I'm going to be finding calculator approximations of each of these values here given to us. So what we need to do, because all of these values inside of our functions, our trig functions, are in radians, we got to go into mode and make sure our mode is in radians rather than degrees now. So now escape out of that and then simply plug in sine of 3.42 And there we go. That is our approximation for this one right here. So go ahead and write that down on your page. And then let's go ahead and do tangent, part B here. Tangent of point 8234, 82, and then hit enter, and you've got that answer right there for you. Now C and D are a little bit different, and these are reciprocal functions. So secant, if you remember, is 1 over cosine. So that's how we're going to plug it into the calculator. 1 divided by cosine, and then of our 5.6041. Oops. 41. There we go. And then we hit enter. That right there is our secant of 5.6041. Now let's do D in the same way. Remember, a reciprocal function of cosecant is sine. So we're going to say 1 divided by sine of the negative 2 point, whatever that is, 2.7335. Then hit enter, and you've got it. That's it right there. Now the next example is also done with the calculator. Okay, this one here again asks us to approximate the value of s on the interval of 0 to pi over 2. That means between 0 and 90 degrees. If sine of s is equal to this value right here. So how we do that is just like we've done before. I'm going to go ahead and write that in. How we found s before, or theta, is by this function's right here, the inverse of it. So sine inverse of our number given to us is how we're going to find our value for s. So s is equal to, now let's go back to our calculator and plug it in. So inverse sine, the second sine of 0.321. And it doesn't matter if you put a 0 in there or not. Then we go enter, and you've got what we are looking for right there, the 0.32678. And you can round this, I say, to the nearest how many ever decimal places this gives you. I want you to round to on your homework. So there you go. Round to the nearest 4 decimal places. Okay, so I guess that is actually the end, and I will see you all in class. Goodbye, everybody.